Good afternoon. The topic is on sterilization indicators and ensuring safe consumables. In the sterilization process, all the living microorganisms and their spores are destroyed and eliminated from a fluid or solid. To ensure the completeness of sterilization process, it should be validated. This validation can be achieved by using the sterilization indicators. The indicator monitors the sterilization parameters, thereby we can validate the sterilization process. Sterilization parameters are the critical variables of sterilization process. So compromising these parameters will lead to incomplete or failure of the sterilization process. For steam sterilization, the parameters are time, temperature, pressure and steam penetration. For ATO sterilization, the parameters are time, temperature and gas concentration. When should the validation be performed? It should be performed in every cycle of sterilization process. Whenever a new sterilizer machine is installed, it should be validated. And if there is any major repair or preventive maintenance work is carried out, sterilization should be validated. The validation test can be classified into three methods: physical, chemical and biological method. Coming to the physical method, the machine printouts, the machine display readings and the gauges are examined. We have to verify whether the cycle is processing in specified cycle time, temperature and pressure, etc. In ETO sterilization, sterile time, aeration time, gas concentration and the temperature to be verified in the machine display and also in the printout. The second is chemical method. Chemical indicators are used to monitor whether the sterilization parameters have met the sterilization specifications. It works by using chemicals that undergo a physical and chemical change when exposed to the critical parameters. By visually observing the color change, it can be interpreted whether it is pass or fail. There are 6 classes of chemical indicators. Class 1 is process indicator. It responds one or more critical variables of the sterilization process. Example, 3-line indicator and autoclave tape. It should be used on each pack. Class 2 is specific use indicator. It tests air removal during vacuum phase. Example, Bovidic test. It should be tested daily as first cycle in the empty load. Class 3 is single variable indicator. It monitors only one variable. Example, temperature tube. Class 4 is multivariable indicator. It responds to or more variables. Example, chemical indicator strip. Class 3 and Class 4 are not used as routine since it does not monitor all the critical variables. Class 5 is integrating indicator. It monitors all the critical variables. Example, chemical indicator strip. It should be used on each bin. Class 6 is emulating indicator. It monitors all the critical variables. Example, chemical indicator strip. It should be used on each bin. The types are not ranked by level of importance. Each type simply denotes performance characteristics. It has no hierarchical significance. For E2 sterilization, class 1 is process indicator. It monitors one or more critical variable. It should be used on each pack. Class 2 is multivariable and class 3 is single variable. Both are not used as routine. Class 4 is a chemical indicator strip. It responds to the stated values of two or more critical variables. It should be used on each pack. Class 5 is a chemical indicator. It responds to all the critical variables over a range. It can be used on each pack. When coming to the 3-line tape, that is class 1 indicator, the tape can be labeled with the details of operator initial, sterilizer ID, load number, number of bin, sterilization date and the expiry date. The first picture is showing the indicator labeling gun. By using this gun, we can set the number and letters and make print on each tape. This indicator should be tested on each instrument tray, each pack and on every bin. When we are exposing it to the sterilization process, the chemical indicator changes its color. After exposure to steam sterilization, the pink color will change to black. And for ETO, color will changes from blue to green. When we are looking at the color of the indicator itself, we will be able to know whether the pack has gone through the sterilizer process. Class 2 is Bovidic test. This test is performed to check air removal during the vacuum phase of steam sterilization cycle. During vacuum phase, the environmental air is replaced with fresh air, that is steam in the chamber. In the Bovidic kit, the indicator card is placed at the middle of a set of cards. The pack is placed over the chamber drain. The autoclave is operated in the Bovidic setting at 134 degrees Celsius for the sterilization time of 4 minutes. When the cycle gets over, the color changing pattern is verified to check the sterilizer function. If the color changes from blue to black with clear lines, which means there is no air entrapment and it indicates that the sterilizer functions properly. If the result does not meet with acceptance criteria such as insufficient vacuum, leakage, non-condensed gas, superheated steam, wet steam, etc., we need to check the sterilizer fault and the issue has to be rectified. Class 5 is an integrating indicator. It contains temperature sensitive chemical pellet. Under high temperature and pressure, it melts and starts to move along the strip. If it reaches the accept line, it indicates that sterilization process has met all the parameters. If it does not reach the accept line, it indicates that the sterilization process has failed. Class 6 is an emulating indicator. It is designed to react all critical variables for specified sterilization process. This indicator changes the color only when it reaches the specified time, temperature and steam penetration. So the class 6 indicator is better than class 5 indicator. For the ETO sterilization, class 4 chemical indicator strip is used. It monitors all the critical parameters such as temperature, time and gas concentration. The color changes from brown to green. Third is the biological method. This is the gold standard method for sterilization validation because the biological indicator directly monitors the lethality of a sterilization process. The indicator vial contains live spores of living organisms which is most resistant to lethal effects of that particular sterilization process. For the steam sterilization, spores of Geobacillus stereothermophilus is tested. For E2O sterilization, Bacillus atropius spores are tested. The biological indicator is passed through the steam sterilization process. After that, it is incubated at 56 degrees Celsius for 48 hours. Then the color change is observed. If the fluid remains purple color, it indicates that there is no growth of bacterial spores. The sterilization process achieved killing of all the bacterial spores. If the color changed to yellow, it indicates the bacterial spores are not killed in the sterilization process. So the process is incomplete or failed. For ETO, after sterilization process, the indicator is incubated at 37 degrees Celsius for 48 hours. If the color changes from blue to yellow, it indicates sterilization failure. Helix PCD test. Helix test instrument is a long hollow tube in which chemical indicator strip can be placed. In this we can use class 2 or class 5 indicator or we can use the biological indicator. Then it is placed in the autoclave or ETO sterilizer with relevant indicator for the validation process. It confirms the sterilizer function, that is air removal, steam penetration and achievement of critical parameters in the most inaccessible areas like tubular instruments. So documentation. To ensure the compliance with regulatory requirements, all the processed indicators should be verified by the senior staff and then documented in the relevant registers. If the indicator showed failed result, the sterilizer should not be used for sterilization process and the materials sterilized in the faulty sterilizer should not be used. Then appropriate corrective and preventive actions to be taken. The sterilizer can be used only after getting the valid results. If the items have been issued, recall all the items. If it is used, follow-up of the patients to be done. So always validate the sterilization process, follow the frequency, verify the validation results, complete the calibration and preventive maintenance schedule, avoid recall and ensure safe use of sterilized materials. Along with the sterilization process, we have to be careful and the surgical consumables also. Consumables are necessary supplies for the surgical system, for example, irrigation solution, eye drops, ointments, etc. Before using the consumables, look for any color change, denatured solution, frothing, and leakage of the pack. If any of the issue is present, do not use the product. If the issue is observed in more than one pack of a same particular batch number, do not use the particular batch. Then identify the causative agent, immediately notify the manufacturer and then return it to the supplier. When a multi-dose vial is used on more than one patient, follow the aseptic procedures. Make sure the nostril of medicine vial does not touch the patient's eye. Even if the container is not emptied, dispose at the end of day. Irrigating solutions, for example, balanced salt solution, ringer lactate, glutasol, etc. In case of any issue or contamination in a particular batch number, it will lead to an adverse event. So it is necessary to do pH and culture test of one random sample in each batch. After getting the culture results, the batch can be used. Each pack should be looked for clarity of the solution. The pack or bottle is checked against black and white background under the light source. Any contamination or denature may cause turbidity of the solution. The fungal contamination may look cottony appearance. So it is necessary to check each pack. So to conclude, follow the sterilization and validation protocol. Ensure that the consumables are sterile. By stringently following all these, we can avoid infections or inflammations due to the improper sterile supplies and consumables. Thank you.